Welcome student, I am Mr. Abhijit Bambre working as assistant professor at Gokhale Education Society's Arts, Commerce and Science College Jawhar. Welcome you again. Student, in last video we learned atomic spectrum of hydrogen atom. In that the only electron of hydrogen atom occupy the first level of the lower energy in a normal or ground state. When energy is imparted to hydrogen gas in the tube, electron move to higher energy level with value n is equal to 2, 3, 4, 5, 6 or 7 depending upon the quantity of energy absorbed. From these higher energy levels means N2, the electron return by the jump to the one of the other lower energy level, that is N1. Means when electron get excited, they goes lower energy level to higher energy level and it come back from higher energy level to lower energy level, that is it come back means higher energy level, where a higher energy level is N2 and it come back to a lower energy level, that is N1. So there is a various series of hydrogen spectrum that are given, or that we learn in last video. Just we revise various series of hydrogen atom. It's an important part. Various series of hydrogen atom: Lemon series, Balmer series, Sachin series, Brackett series and Fernd series. N1, N2, spectral region and shell. Lemon series. Lemon series is arise when excited electron from higher energy level, that is N2 is equal to 2. When excited electron from higher energy level, that is N2, higher energy level, that is N2, and they are returned to ground level or state level, that is N1. N2 is higher energy level, N2 is higher energy level and N1 is lower energy level. When in Lemon series, when excited electron, that is they are excited higher energy level, that is n is equal to 2, they are come back or they are returned to ground state or lower energy level, that is N1 is equal to 1. The first energy level are in K shell, where n is equal to 1. In Lemon series, higher energy level N2 is equal to 2 and N1 is equal to 1 and shell is K shell. Then Balmer series. In Balmer series, the series arise when excited electron from higher energy level, that is N2 is equal to 3 and they come back or return to lower energy level, that is of shell L, that is n is equal to 2 or N1 is equal to 2. Sachin series arise due to transition of the excited electron from the higher energy level, that is N2 is equal to 4 and N1 or N is equal to 3 in M cell. Bracket series arise due to transition of excited electron from higher energy level, that is N2 is equal to 5 and N is equal to 4 in N shell. Fernd series, N2 is equal to 6, 7 etc. and N1 is equal to, it is an lower energy level. Various series of hydrogen spectrum, that is a Lemon series, Balmer series, Paschen series, Brackett series and Fernd series. And there is spectral region. Lemon series spectral region are ultraviolet, Balmar are visible region, Paschen series are shows in infrared, bracket series are far from infrared, and front series are also in infrared region. Lemon series, that there is two energy level, N2 means higher energy level and N1 means lower energy level. When higher energy level N2 is equal to 2 in lemon series, N2 is equal to 2, it transmitted to lower energy level, or they come back to lower energy level where N is equal to 1 in K shell, right? Then N2, where in Balmar series N2 is equal to 3, they are come back or return to N1 level or ground level or lower level where N2 N is equal to 2 in L series. Means their electron are excited electron get transmitted from higher energy level to lower energy level in different cell, that is K cell. Lemon series are N is equal to 1 in K shell. Balmar series N is equal to 2 in L cell. In Paschen series N is equal to 3 in M cell. In bracket series N is equal to 4 in N cell. Next, we start new topic, that is periodic table. As we know, who created it? They are systematic arrangement of element started with the discovery of individual element by in 1860 about 60 elements were known and a method was needed for a organization. In 1869, Russian chemist Dmitry Mendeleev proposed an arranging element by atomic weight and their properties. As we know, in inorganic chemistry deal with a element and their compound of a study of the properties of elements, so that some group of element had many similarities, and this suggests that the property of element were governed by the some principle or some laws. There is so many law are put forward for the same study. It was realized that once this law underlying a principle was known, the ever increased mass of knowledge could be arranged in such a systematic manner that it will become a both useful and relevant. Mendeleev was one of the Mendeleev was one of the several persons who undertook the study of the element. He was not the first person to take up this task, but what made Mendeleev's work so significant was that he was able to classify the element, then known on the basis of their properties. And what is that properties? What is the periodic law? The periodic law. Mendeleev understood the periodic law. They state, when arranged by the increasing atomic number, the chemical element display a regular and a repeating pattern of chemical and physical properties. Next, actually, periodic law means what? The properties of element are a periodic function of their atom. The periodic law. Atoms with a similar properties appear in a group or families. There are so many atoms with a similar properties appear in a group or families. Group it in vertical column or on the periodic table. group or families. It's an vertical column on the periodic table. They are similar because they all have the some number of valence in outer shell electron which govern their chemical behavior. The outermost shell of electron which govern their chemical behavior. Next, see the periodic table diagram of the periodic table. Column, here is column means a group or a family. There is 18 column on the periodic table. 18 column. Here is it is an vertical column are called as group. See here is an column or group. There are in periodic table there are 18 group. There are 18 column or 18 group. Row means period. There is 7 rows on the periodic table. See here 1, 2, 3, 4, 5, 6 and 7. It is an actinide and lanthanide series. So in periodic table, listen, in periodic table column means a vertical column is called as group. There is 18 column or 18 group, and there is in periodic table there is horizontal rows like this. There are horizontal rows and rows are called as period. There is 7 period in periodic table. 18 group in periodic table. There is 18 group. Group means column, vertical column. There is 18 vertical column, and period means horizontal rows. There is 7 rows or 7 period. Group means column and row means period. Got it? Next, periodic table. There is periodic number. There is block, S block, D block, F block element, P block element, group 1 to 2. Group 1 to 2. Group means vertical lines, vertical column. Group 1 to 2, they contain S block element. Group 3 to 12, it contain D block element. Group 13 to 18, it contain P block element. And here is an lanthanide and actinide series are F block element. It's depend upon the outermost shell electronic configuration. Next, block, part of periodic table, similarities in element. S block, group 1 and 2. Outer shell electron are in the S subshell, that is S1 and S2. Got it? And P block, group 13 to 18. Outer shell electron are in the P subshell, that is S2 P1 to S2 P2. Transition metal, group 3 to 12 are the transition metal. The D subshell is being progressively filled, that is D1 S2 to D10 S2. F block contain lanthanide and actinide series. The F subshell is being progressively filled. See here, it is an periodic table. It start there is 18 column or group and 7 rows, and here lanthanide and actinide series. How do I find the number of proton, electron, neutron in an element using the periodic table? Proton is equal to atomic number. Electron, it means atomic number, and neutrons means atomic number, atomic weight minus atomic number. What does the information in the box? See here, atomic, it's denote, here is element or elemental symbol, it is an hydrogen atom. It is a simple example, it is an hydrogen atom or it is an elemental symbol, right? Here it's denote atomic number means proton, and here it is atomic mass, it means proton plus neutron. Here see, it is elemental symbol, it is an hydrogen symbol for hydrogen. See here, here is atomic number and here is atomic mass. Atomic mass means proton plus neutron. Next, the element of the periodic table can be divided into three main categories: metal, non-metal and metallite. Metal, non-metal and metallite. See here, there is color differentiation, there is a different color for metal, non-metal and metallites. What is metal, non-metal and metallite? There is a different position for non-metal, there is a different position for metal, and there is a different position for metallites in the periodic table. Metal, non-metal and metallite. There is a zigzag or staircase line that divide the table. Metal on the left of the line in the blue. See here, there is main group, a subcell field, there is metal, non-metal and metallite. Metal are on the left of the line in the blue, non-metal are on the right of the line in orange. Metals, as we know, metal are shiny, malleable, ductile and are good conductor of heat and electricity. They are mostly solid at room temperature. There is some example of metal. Then non-metal are the opposite to the metal. They are dull, brittle, non-conductor or insulator of an electricity. Some are solid but many are gases, and bromine is a liquid from non-metal. Metalloids are semi-metals, are just that they have characteristic of both metal and non-metal. They are shiny but brittle, and they are semiconductor. See here, periodic table: alkaline metal, alkaline earth metal, transition metal, then non-metals and metalloids. Their position given in the, hey, see here, there is column. First there is alkaline metal, then alkaline earth metal. See column, there is transition metal, position of transition metal, and non-metal or metalloid position, and noble gas. See here, 18th group, and lanthanide and actinide series. So student, in periodic table, horizontal rows of long periodic table are called as period. Horizontal rows are called as, it is an horizontal row, it's called as period, whereas vertical column are called as group. There is 18 group and 7 period. Each period being with an element whose outermost shell configuration is ns 1. A period end with an element whose ns and np orbital are fully occupied, that is ns2 nsp6. The period number indicates the number of cells present in each of the element in that period. It indicates that large cell number means n is in each of the element, means it indicates the number outermost cell is fulfilled or not. Thank you.